Hello, online. Can you hear me?
Yeah, we can hear you.
Okay. Hi. How are you? Good. Okay, today we will cover chapter 4A. Online. Seeing okay?
Yes, sir.
Okay. And then hearing okay, right?
Yepers.
Yep.
Yeah, because today I try different type using a school computer instead of my laptop. So maybe somewhat different from last time. Okay, learning curve. Earlier, we mentioned about the experience curve and this learning curve briefly. From previous doing, we learn something and then experience something. So based on that previous learning, we can do same job again and again. Then we can reduce time, make it faster, or cost too. But that is a learning curve. Learning curve is a line and then display like this. And then the cumulative number of units. And then unit of, just a moment. This one, unit production, time, and the cumulative number of units. So increase number of units and then unit time decrease like this. So if first time it takes 100, whatever time unit, and then next time 90 and 84, 62, and so on. And then there are some underlying principles of learning curves. Each time of performing a task, it takes less time than the last time to perform the same task. As you can see, first time 100, next time 90, and so on like that. The unit time will decrease at a decreasing rate. I'm not sure if it works. Okay, from 100 to 900, difference is 10. 100 minus 90. And then from 90 to 8462, that is 5 point. Difference is 5 point. 38. The next one from 8462, 81. Difference is 3.62. And next, 81 to 78.3, that is 2.7. Difference is 2.7. The next, 4, 1, 2, 2.14. So decrease the unit time with decreasing rate. 10, 5.38, 3.62, and so on. The reduction in time will follow a predictable pattern. We don't know next one, 7th. We don't know, but we can predict because we know pattern, like the 3.62, 2.7, or 2.14. Maybe difference is like 2, less than 2.14 or 1 point something. Let's say difference is 2, then 74, about 74. Because we know pattern, we can predict like this. And then the learning curves can be used to estimate the time for product design and production. We can use predict time, and also we can predict cost. This is the learning curve underlying principles. Okay, next. There are 2 types of learning curve. First one is arithmetic learning curve. This one is the simple exponential curve. If learning percentage is 90%, 80%, and 70%, looks like curve. 90%, not much, but 80%, more and more. I will tell what is the learning percentage with the next slide. So this arithmetic learning curve is the simple exponential curve. So with this arithmetic learning curve, there is kind of a rule. When the unit time is doubled from 1 to 2, 2 to 4, 4 to 8, 8 to 16, if learning percentage is 90%, that means from 100 to 90, 90%, about a previous one, 80%, 80%, 70%, 70%. Then learning percentage is 90%, 80%, 70%. Then we can denote learning percentage as B, letter B as a boy. So when it's doubled times B, here B equals, if learning percentage is 90%, B equals 0.9, 0.8, 0.7. So when it's doubled, the unit is doubled, then just simply times B 0.9. Here, if learning percentage is 80%, B is 0.8 times 0.8 and 0.7 here. So from 90 to 81 times 0.9 because it's doubled from 2 to 4. And then 81 to 70 to 90 because it's doubled from 4 to 8 times 0.9 and 0.8, 0.8, 0.8, 0.7, 0.7, and so on. This is arithmetic learning curve rule. Any questions so far? Okay, good. Next one is logarithmic learning curves. This one is relatively straighter than arithmetic learning curve. Because if we use arithmetic learning curve, we cannot get third one. If we know we know learning percentage, then we can get fourth, and then eighth, and so on. But we cannot get third, fifth, sixth, and seventh. But if we use this logarithmic learning curve, we can get any unit, third, fifth, and so on, using this formula. Unit time yx, axis unit time equals the first time for first initial time, like 100. If it takes 100 minutes to produce the first one, this k is number of direct labor hour or cost for the first one. So k times the initial cost or time times the unit number. If we know we want to get like in the fifths, that is 5. And then n is n power, n is log b divided by log 2. B is here learning percentage, 0.9, 0.8, 0.7, and so on. Okay. Unit improvement factor. Unit improvement factor. When we calculate like we want to get like now y eighth, then it will be k times the initial cost or time times unit factor at eighth, and if we want then learning percentage 80%, then 80%. This one is the same as k times if we use logarithmic learning curve. X is 8, and then log 0.8b divided by log 2. It's okay if you use logarithmic learning curve formula or using find unit factor from table. Either way, fine. From the chart, here, unit factor eighth at eighth and 80%. So unit number is 8. This chart is attached. The first one, unit improvement factor in your lecture note. So find unit factor 8th and 80%, 8th and 80%. So unit factor, this part is 0.520 from the chart. I will bring, at the moment I will show you. Where it is. On lecture note, in lecture note, there are two charts. The first one, this one, is unit improvement factor. So using this chart, you can find the unit factor. Like this. So the unit improvement factor, I call this one unit factor, UF. So unit factor is 0.5120. Then if you use logarithmic learning curve formula, then y 8th equals k times, we don't know k, but x n equals k times x is 8, the n is log 0.8 because 80%. 80%, 0.8 divided by log 2. So that is k times 8. So log 0.8 divided by log 2, that is negative 0.32 193. If you have a calculator with log function, try this one. Log 0.8 divided by log 2, then it is negative 0.32193. So this part is the same as unit factor eighth at 80%. So that is same as 0.5212. So this one is the same as k times unit factor. So unit factor, this one equals x n power log b divided by log 2, the same. Question so far? Okay, good. Clear. The next one. What is cumulative improvement from unit 1 to 10 at 90%, 90 learning percent? Okay, unit factor and cumulative factor. Learning curve looks like this. So this one, I'm sorry, no, this one not good. First one, second one, third one, and so on. Then this individual unit, time or cost, we can use unit improvement factor if we need kind of area from 1 to 10 or any range from 10 to 20, 20 to 50, something like that. We can use this cumulative improvement factor. I call this one cumulative factor, CF. So cumulative factor is the same as like this. From 1 to 10, CF, cumulative factor 10, that means from 1 to 10 equals unit factor 1 plus unit factor 2 plus 3, 4, 5, 6 up to unit factor 10. This is the same as like this. Cumulative factor means if we have given a number like 10, then from 1 to 10 area, so unit factor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Somehow like that. So that is the kind of concept. with unit factor and cumulative factor. So we can use the second table in your lecture note. Second chart is cumulative improvement factor. I call it as cumulative factor, CF. So 90% and 10. That is 7.994. 7.994. So I think you can find unit factor and cumulative factor from the chart. Any questions so far? Okay. Now, how can we use unit factor and cumulative factor to calculate unit time or cumulative time or cost? Okay, if unit number 1, 2, 3, 4, 5, 6, 7, 8, then cost, initial cost, we don't know. K is not given yet. But second one, 102, third one, 92.75, fourth one, 86.7, and so on. Then, first question, estimate the learning percentage and K. We don't know K, and then learning percentage is not given. As long as if we know second one and fourth one, or fourth one and eighth one, then we can get learning percentage and K, initial cost. The relationship from arithmetic learning curve concept, when it's doubled, times B. Am I right? So, y second, let's say y fourth equals y second doubled when it's doubled from 2 to 4 times B. Am I right? When it's doubled from 2 to 4, 2 to 4 times B. So y fourth, this one equals y second times B. So y fourth is 86.7 equals y second 102 times B. So from this one, B equals divided by 102 each side. This one is like this. B equals divided by y second each side. Then it's gone because the same, the result is 1. So B equals y fourth divided by y second. If you know y eighth, then divided by y fourth. Half of this one, or doubled, then you can get B. So B equals y fourth 86.7 divided by 102. Okay, can I erase? So B equals y fourth divided by y second equals 86.7 divided by 102 equals 0.85. So learning percentage for this example is 0.85, 85%. Now, we want to get K. The same, y second equals K times B. So K equals divided by B each side, y second divided by B. Y second is this one, 102, and then B is 0.85. So K equals y second divided by B, 102 divided by 0.85 equals 120. What do you think? Make sense? If you think it makes sense, then you understood. But, oh well, maybe you need practice, okay? Then, next question. Estimate the cost to produce the 20th unit. So 20th unit, y 20th at 85% equals K times unit factor 20 at 85. This one is the same as if we use logarithmic, then equals K times X n equals K times 20th, X is 20, and then log 0.85 to divided by log 2. So this part is the same as unit factor 20. So that is from the chart, the first one, 20 and 85, 0.4954. So 120, K is 100.4945. If you calculate this one using calculator, then the same 0.4954 equals 59.448. Question? Okay, good. And next question. Estimate the cost to produce the 30-second. This one is Y 30-second at 85%, because now learning percentage is 85 equals K times, K is 120, and then unit factor 30-second at 85%. So try to find unit factor 30-second Try to find the 30-second, but we cannot find. In that case, there are two ways. From arithmetic learning curve concept, 30-second, if you don't know 30-second, if you cannot find, then try divide by 2. Because times 2, then times b. So if you can find half of that one, unit factor, then divide by b. So it's like this. If you can find half of 30-second, so to get 30-second times b. So find 16ths and then times b, then this total is unit factor 30-second. From arithmetic learning curve concept, or you can use K times 32, X is 32, and then log 0.85 divided by log 2, the same. Either way. So from the chart, I will use the arithmetic learning curve concept. So if we can find 32nd, then half of that one. If we find, then times b. So I can find the 16th, 0.5220. So 120 initial, unit factor 16th, 0.522 times b. So this is unit factor 32 equals 53.24. Question? Okay, now estimate the cost to produce 40 units from 11th to 50. So this one looks like area like this from 11 to 50. So 11 to 50. So this area is 40 units. Because cumulative factor gives you from 1 to certain number. So to get this one, you need find up to 50, this area, minus up to 10. Because we need from 11 to 50, we subtract up to 10. If question asks you find like 6 to 10, then you should find 10 minus up to 5. Because we need from 6. You know what I mean? Okay? So, y 11 to 50 cumulative at 85 equals k times cumulative factor from 11 to 50, that is the same as k times cumulative factor 50 minus cumulative factor 10. Because we need from 11, so subtract up to 10. Keep in mind, don't subtract up to 11, subtract minus 1, where the area starts. So cumulative factor 50 and 10 at 85 from chart. Cumulative factor 50 at 85, 25.51, and 10, 7.116. So plug in K equals 120 times cumulative factor 50 is 25.51 minus 7.116 equals 2,207.28. Question?
Yeah, where about did you get the 10 if we're doing the from the 11th to the 50th?
I'm sorry. This side, the hearing is not good. Just a moment.
Can you hear me now?
Sorry. My earphone doesn't work. Let me check the sound. Could you say something?
Can you hear me now?
I can hear, but very little. I'm sorry.
Let me just email you or type it in the chat if that will
Okay.
work.
Later, if you need you need like a tutor, then email me and then set a time to meet individually. Okay. Okay. I think that's all for today lecture. And then next on next Monday, the same in class and Zoom. I think I should go back to the previous method using my laptop, and that is not better work. And then maybe next Wednesday, I try online only. So next Monday, it's the same in class and Zoom online and like an asynchronous, and then record and then later post. And then next Wednesday, I think it will be online only. Next Monday, I will announce again. Okay, next Monday, we will cover practice problem, and then there will be one assignment. So like last time, I will go over a previous assignment question. Okay? If your question today it is not good, so if you need me, email me and then set up a meeting. Okay? Okay? Okay, thank you and see you next Monday.
Thank you.
Thank you.
Have a good weekend.
Good weekend. Bye.
Thank you. Bye.
Thank you. Bye.
Thank you.